Welcome back to my channel. In this video, we are going to talk about more properties of exponents. So in two other videos that I shot, I talked about the power rule and the product rule. So hopefully you watched those by now. In this video, we're going to talk about the zero exponent rule, the negative exponent rule, and the quotient rule. So let's get started. We're going to first start with the zero exponent rule. The zero exponent rule says that anything raised to the power of zero, so a to the 0 is equal to 1. So anything we raise to the 0 power is 1. That is the zero exponent rule. For example, when we want to evaluate these three different exponential expressions, the first one is 60 to the 0. So according to the zero exponent rule, anything raised to the 0 power, and we have 60 to the 0, is equal to 1. So this would just be equal to 1. All right. Now this one is a little different because it says negative 60 to the 0. This is the same as saying negative 1 times 60 to the 0. Well, we know that 60 to the 0 power is 1. So then this is the same as saying negative 1 times 1, which is equal to negative 1. So your answer here will be a negative 1. And that's because you have this negative in front. So 60 to the 0 is 1. Basically, you replace 60 to the 0 with 1. You still have that negative in front. Now, it would be different if the negative was in parentheses. If it was negative 60 to the 0, then that whole answer would be a positive 1. Hopefully, that makes sense. All right, now for this one, this is 6 times y to 0. And the reason I write it like that is because this is not saying raise the 6 and the y to the 0. It's only saying raise the y to the 0. So y to the 0 is 1. So this is the same as saying 6 times 1, which is equal to 6. So the moral of the story is you have to pay attention to what's being raised to the exponent. So if it's only, if it's not in parentheses, then it's only referring to the thing that it's next to. So this is not in parentheses. So this is only raising 60 to the 0 power. This is not in parentheses. So it's only raising the y to the 0 power. The next property we're going to talk about is the negative exponent rule. So the negative exponent rule it says if you want to raise something to a power that's negative, then what you have to do is you have to rewrite it as a reciprocal. So rewrite that under 1, and then the power or the exponent becomes positive. So this is the negative exponent rule. You make it a reciprocal, and then your exponent, which was negative, now becomes positive. Let's look at some examples. For example 2, we want to evaluate all of these exponential expressions, and they all involve negative exponents. So the first one is 3 to the negative 2. So according to the rule, if it has a negative exponent, you make it a reciprocal, and then the power becomes positive. So that will become 1 over 3 squared, and then you would evaluate 3 squared. 3 squared, it's 9. So this will be 1 over 9. That would be your final answer for that one. So this one, we have a fraction to a negative exponent. So you still make it a reciprocal. Since it's a fraction, you make it a reciprocal and the exponent becomes positive. So you just flip the 1/2 and make it 2 over 1. And then it'll be 2 over 1 to the 3rd power. So whenever it's a fraction, you just flip the inside and make the exponent positive. And then you have to raise both the numerator and the denominator to that power. So 2 to the 3rd is 2 times 2, which is 4, times another 2, which is 8. 1 to the 3rd is 1. 8 over 1 is 8. So that final solution for part B will be 8. And you will do the same thing with part C. It's a fraction, so you'll flip it. That'll become 5 over 2 to the 4th. That's the same as 5 to the 4th over 2 to the 4th. That's the power rule, which we talked about in the previous video. 5 to the 4th is 5 times 5, which is 25, times another 5, which is 125, times another 5, which is 625. And 2 to the 4th is 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So this is 625 over 16. That will be your final solution for part C. So this is how you would simplify using negative exponents. In example 3, we want to work another example or evaluate some more expressions that have negative exponents. So again, here we have a fraction. In this case, it's a little different than the last one because last time our whole fraction was raised to a negative exponent. This time only the denominator is raised to a negative exponent. So that denominator is what will actually flip. So x is the same as x over 1, or as you can see, if it doesn't have a 1 underneath it, when you flip it, it gets 1 on top. So this becomes 1 over x to the 4th. But we're dividing a fraction. Whenever you divide a fraction, you do the keep, change, flip. You keep the numerator. So the numerator 1 stays the same. You change the operation of division to multiplication. And then you flip the denominator. So 1 over x to the 4th becomes x to the 4th over 1. So you do 1 times x to the 4th, which is x to the 4th. 1 on the bottom, which is just x to the 4th. So we did all of that to say, basically, you just flip this and change the exponent to positive. So x to the 4th is your final answer. For part B, the only thing being raised to negative exponent is the y. So we only put the y in the bottom and make the exponent positive. And there's nothing left to do there. So that will be your final answer. So basically, whenever you have a negative exponent, you just move it in the opposite. So if it was in the denominator, you put it in the numerator. If it was in the numerator, you put it in the denominator. For example 4, we're just going to work some more examples just so you can get the hang of using these different properties together. So here we have negative exponents. So again, since this has a negative exponent, I'm going to put it in the bottom since it was in the top, and that exponent will become positive. Since this has a negative exponent, I'm going to put it in the top, and then that exponent will become positive. So that becomes 5 to the 3rd over 4 squared. 5 to the 3rd is 5 times 5, which is 25, times another 5, which is 125. 4 squared is 16. So your final answer here would be 125 over 16. For this one, since a to the negative 2 was negative, we're going to put it in the bottom and it'll become positive. So b will stay in the top because it doesn't have a negative exponent. 3 will stay in the bottom, and now this a will go to the bottom and the exponent will become positive. And because this d had a negative exponent, it will go to the top and become positive. And there's nothing left to do, so that will be your final answer. So basically all you did, there's nothing to combine to simplify, so that's why you stopped there. But basically all you did was take the negative exponents and switch where they were. So this one has a negative exponent, it's a fraction, so you'll flip the whole fraction and make it to the 4th power. But now you have to take this numerator and raise it to the 4th power, and you have to take this denominator and raise it to the 4th power. Well, here you have two things being raised to the 4th power, so now you have to raise both of those to the 4th power. 2 to the 4th is 16. 2 times 2 is 4, times 2 is 8, times another 2 is 16. So that becomes 16y to the 4th over x to the 4th. And so there's nothing left to do there, so that will be your final answer, 16y to the 4th over x to the 4th. So that's another example, or those are more examples of working with negative exponents and a lot of the other properties of exponents we've talked about. There's one more rule, property of exponent that we need to talk about, and it's the quotient rule. And it's the rule that says if you're dividing two things that have the same base, then you can combine those by subtracting the exponents. So if we're dividing and we have the same base, then we can combine those two bases as one base by subtracting those exponents. So for example 5, we want to evaluate 5 to the 8 divided by 5 to the 6. They have the same base, they're being divided, so we can use the quotient rule. So we would combine those two by subtracting the exponents, and that becomes 5 to the 2nd power, which is equal to 25. So that ends up being 25. For example 6, we want to evaluate 3 squared x to the 5th divided by 3 to the 4th x to the 3rd. And so basically we have two separate things with the same base that's being divided. So I'm going to break it up as 3 squared over 3 to the 4th times x to the 5th over x to the 3rd. So I wrote the 3's together and I separated and wrote the x's together. Now because I'm dividing and the bases are the same, I can use the quotient rule for each of these. So this will become 3 to the 2 minus 4 times x to the 5 minus 3. If I subtract 2 minus 4, that's negative 2. If I subtract 5 minus 3, that's positive 2. Because this has a negative exponent, we have to rewrite it in the bottom or in the denominator. And so this will be x squared over 3 squared. And 3 squared is 9. So this will be x squared over 9. So x squared over 9 will be our final solution to this problem. Okay. I know I've done a lot of examples in this video, but this is the last one. I promise you. We're going to do 4 squared to the third divided by 4 to the fifth. And this just uses multiple properties. So the first thing we have is the power property here. We have an exponent being raised to another exponent. So you can combine those by multiplying the exponent. So 2 times 3 is 6. So that becomes 4 to the 6. So now we have two things being divided that have the same base. So now we can actually use the quotient rule. So we would combine those by subtracting the exponent. 6 minus 5 is 1. So that will become 4 to the first power, which is 4. So your final answer here would be 4. And so that is how you use the quotient rule. So in this video, we did the zero exponent rule, negative exponent rule, and the quotient rule. In the previous videos, we did the product rule and the power rule. So using all those properties of exponents, you should now know how to work with exponents. And you'll need this in this class. You'll need this in the next class. You'll need all these basic properties in any math class that you take that is algebra related. So if you have any questions, make sure you put them in the comments below. If you like this video, if it helped you, give it a like, hit the like button, give it a thumbs up. And if you haven't already, make sure you hit that subscribe button and the bell, because you'll get notifications every time I release a new video. Thank you for tuning in. I hope you're doing great in your math class. Remember, you can do anything you put your mind to. You just got to work hard at it. You do whatever you desire. So I'll see you in the next video. Thanks for tuning in.